In the previous video, we finished our slides. We ended on slide 20, and we are interested now in joining these two tables together in a select query. We determined that there is a common field between the two tables. If we look at slide 18, we can see that there is a store ID in the employee table, which is a foreign key because of the way it's named. And there is a store ID in the store table, which is a primary key because of the way it's named. It's named store ID, has the same name as the table without the T, plus it has ID appended to the end. We know this is a foreign key because the store ID is not the same name as the table, but it has ID at the end. These are conventions that I follow in my database development. They are not rules. They do not tell SQL Server anything. They do not tell SSMS anything, but they are useful for us. We also discussed that you could look at the design of the table to verify with all certainty that there is a foreign key primary key relationship. So I encourage you to investigate these tables, to study them, look at the design of them. You have my blessing to do that. You're not going to break anything, and you don't have permission to cause problems. So feel free to dig into these tables and look at them in any way you see fit. All right, the question we wanted to answer was that one. We want to know what employees are assigned to what stores. At this point, I think we're ready to jump into SSMS in earnest. Let's bring up a query window. And remember, the purpose of this class is to learn how to write queries. You need to understand the terminology. You need to understand table design, a little bit of theory. And then once you've understood all that, you can write useful queries that can be used as the basis for reports, for web pages, for games, for anything that needs information extracted from a database. So we're going to say what employees are assigned to what stores. Not a perfect question, not perfectly defining everything that we would want to see in this query, but it is a natural language question that is valid. You may be asked to provide information along those lines in the real world. Use grocery store. We used AP in a previous exercise because we were referring to the AP database. Now we're using the grocery store database. So remember, you logged in with grocery store credentials, grocery store login. Now you're saying I want to use the grocery store database. Those are names that I created. They follow each other. They have some logical connections, some semantic connections. So it's a little bit easier to follow along with what credentials to use with what database, since the database name has the same name as the login that you're using. Select. At this point, everything we do starts with select. That's pretty easy. How about star? From. And we know there are two tables. There's the employee table, and there is the store table. Now at this point, we have to tell SQL Server how those two tables are related. We've defined it as an inner join, which is the intersection of the two tables, what they have in common. How do we join those two tables? How about TEMPL dot store ID equals T store dot store ID. Sometimes the help comes up, sometimes it doesn't. And I don't see any squiggles. That means that SSMS is reasonably happy with what we've done, but we'll find out for sure. And there is our result. Now what's useful about this? We have information from the store ID table and information from the employee ID table, from the employee table, in the same result set. Hooray! We have joined two tables together. It's a little bit overwhelming. If you look at the column headings, the first 1, 2, 3, 4, 5 columns out to here are all from the employee table. And the remaining columns, 1, 2, 3, 4, 5, 6, 7, 8, are from the store table. Each row then has all the information from the row in the employee table and all the information from the row in the store table. Look and see that the store ID in the employee table exactly matches the store ID in the store table for each row. That's the join field. That's the foreign key, primary key relationship. So this is pretty exciting now. We can create much more useful result sets this way. But it's a little overwhelming because the star grabs up everything from both tables, and I don't really want that. How about if I just want the employee identifier, EMPL, the last name of the employee, and the store. That's all I want. I'm asking for 2 fields from the employee table and 1 field from the store table. And I click execute. Uh-oh. Made a mistake because I had something highlighted and tried to execute the query as the word store. So don't highlight anything unless you know what you're doing. Be very careful there. And there's my result set. That's a little more manageable. I've got the employee identifier, which happens to be their last name pretty much. I've got their last name and I've got the store they're assigned to. That's pretty exciting. This is an inner join, so we're only asking for records that have a common field in each table. Notice there's only 2 stores listed here. If you take a quick peek at the store table, select top 1,000 rows of the store table, there are numerous stores. There are 20 stores. But only 2 of them have employees assigned to them. Therefore, we only got those stores in our result set. The reason for that is because we did an inner join. We want the intersection of the 2 tables. If you refer back to the slides, there is an inner join. This is slide 12. The inner join is the intersection or the common data between the 2 tables. So don't take this as a list of all stores. It is only a list of employees who are assigned to stores. If there's an employee not assigned to a store, they won't show up in here. If there's a store that has no employees assigned to it, they won't show up in here. Let's talk about some different ways to write this query. The first thing I'd like to do is make it perhaps more readable by putting in some line breaks. This is personal preference. The query may extend out over hundreds of characters. It may scroll off the edge of the screen. This just, for me, makes it easier to grasp. You can experiment with that and see what works for you, but I may ask you to do this in a homework, so be sure that you follow my requirements. The first thing I want to do is introduce an alias for each of the tables. And this matters because you may be joining the same table more than once in a complex query. And it's important to develop some shorthand, make things a little bit easier to deal with, and eliminate confusion, because if there's an overlap between field names, between 2 tables, then you will have a problem. So the first thing we do is we provide a brief identifier for the table name. So in other words, I can refer to this table as E, the employee table, and I can refer to this table as S, the store table. And then I immediately get a squiggle because when you implement the alias not the alias letters, you can no longer use the table names. It won't accept those. This needs to become an E. And this needs to become an S. And now it's happy again. And nothing else changes in the results set. It doesn't look like much now, but when queries get very complex, this helps a lot. And this is a good habit for you to build using the aliases on the table names, and I will be looking for that in your homework. Another thing I can do that we did earlier in a previous lesson was I can create aliases for these fields too. Employee, I don't know, ID, identifier, and an alias for last name, which would be nice to, perhaps to not have to have a space in there. And store is already pretty self-explanatory, but we can still do it. Running this changes the column headings in the results set. Employee identifier becomes the column heading, last name, and then store. Now this is okay. Sometimes it's a hindrance depending on the purpose of the select query. When we eventually turn that query over to someone else, they may use it in a more advanced query. They may use it actually to build more queries. They may use it as the basis for a report. So it's good to get into that habit too of building aliases, but you'll have to get a feel for what a good alias looks like. To recap then, we typically use letters for the table aliases, and we may use a descriptive name for the column alias, or we may end up just using some other alias that is unique but easier to deal with. And you'll see more of that as we go along. You'll get a feel for some style points and what things should look like. But for now, I want you to make an effort to implement aliases for your column names and implement aliases for your table names. Thinking a little bit more about this query, our customer may want this result set ordered somehow. Right now I don't know what order it's in because I didn't ask for an order. Actually I do, but let's just assume that we don't know. We should override the default order, if necessary, by specifying an alias. Now we're in alphabetical order. That's not bad. If you look at the store column, you can see now that the stores are no longer in any kind of order because we resorted the entire result set by the last name of the employee. Keep in mind that once you turn this query over to other developers on your team, they can reorder it any way they want. So the order that we provide may just be overridden by someone who uses this select query in a more complex select query of their own. But it's a good habit to get into, again, to think about what might be necessary for your customer. Do they think they want it to be ordered? And it's okay to ask if you don't have enough information when you're creating the query. What if we just want stores in Anderson? Can we do that? Adding a where clause. Well, that looked right. Didn't we do that last time? Hopefully you recognize that these are just in the wrong order. This clause needs to go here. We're still not right because the single quotes don't work as well. I mean, work better. Sorry, the single quotes work better than the double quotes. There we go. be careful using single quotes and double quotes. When you're quoting a string in SQL Server, single quotes are necessary. What we've done then here is we've joined two tables together on a common field. We provided an alias for all of the tables and all of the attributes. Typically the table aliases are single letters, they may be more. We've sorted our result set by a particular column, and we filtered the result set by a value in another column. So we built up an interesting, useful query in a very short period of time.